presentation, which will be given by Hayet Djellali. The title of this presentation is Adapted Search Equation of Artificial Bees Colony Applied to Feature Selection. Okay, you have 20 minutes to do your presentation.
Firstly, Assalamu alaikum. I introduce myself. I'm assistant professor from Belgium University. I am affiliated to the LS laboratory. I'm delighted to share our work today entitled Adapted Search Equation of Artificial Bee Colony Applied to Feature Selection. I start by introducing feature selection and set the objective of this work, present some element about feature selection and different categories of feature selection approach, introduce artificial bee colony and the main drawback and advantages. After that, I present the proposed method which is adapted search equation of artificial bee colony to applied to feature selection. We validate our experiment, our work by experimental result and discuss the final result and finally conclude. Feature selection is about selecting a subset of features that are relevant for classification problem or pattern recognition problem, and we keep only relevant features. This way we have a minimal subset of features, we reduce the size of data, and we keep only relevant features without loss in accuracy and performance of the system, classification system or pattern recognition system. There are many categories of filter selection approach. There are filter approach where we use the statistical approach to select the final subset of features. The second approach are wrapper approach where we need to use the classifier to evaluate the quality of the solution. Embedded method are feature selection approach where they combine both filter and wrapper approach. And finally, fusion method where they use different feature selection approach, and the final subset is used by majority vote. In our case, we used artificial bee colony, which is a swarm intelligence approach algorithm, where different agents take different action and must execute different tasks. For optimization problem, in our case, we have feature selection problem. We need to optimize we need to get the best subset of features that deliver the best performance. For optimization problem, which is the case for feature selection, we apply artificial bee colony as a wrapper approach. We need for that to apply fitness function, which is the function which defines the quality of the solution. This fitness is evaluated by classifier. In artificial bee colony, we have a different category of bee. We have employed bee and onlooker bee and scout bee. Employed and onlooker bee share the same task, which is exploitation process. We mean by that exploitation is the process of obtaining a better solution, a better source given actual source. Exploitation is about exploration is about finding a new solution to diversify the population and to get stuck in local optima, and this way obtain the best result by balancing between exploitation and exploration. The objective of this work is to present a novel search artificial bee colony called the NSADC to improve feeder selection. The study introduced new search equation for employed and on-local bee by involving more parameters for each food source to avoid local optima. We try to, in this work, we try to modify the search equation to get to balance between exploration and exploitation. Artificial bee colony, the standard algorithm of artificial bee colony starts by initialization of population. From iteration 1 to iteration max iteration, there are three main phases. The first one is employed bee when they search the food source and convey the information to on-local bee, which is the second phase, and on-local bee benefit from the information transferred by employed and optimize the actual good solution and modify the actual good solution. Where Scout bee is the bee specialized on the task to search new solutions when the actual solutions are not enough good to get the best, the global optimum. The last stage is to memorize the good solution and iterate until last iteration. This is the main step in standard artificial bee colony. Our approach tries to modify employed bee and on-local bee by modifying the search equations. There are many works that modify this equation. For example, for Ferran and all, they designed 5 search equation strategy in artificial bee colony. We don't claim that our work is the only work done, but this is another approach. Zhu and Kwang profit from actual best to search in the neighborhood of the actual best and modify the search equation by benefiting from actual best. The proposed algorithm starts by random initialization of population, which are the candidate solution. We compute the number of features to be modified. This is the first modification in comparison with the standard artificial bee colony. In this step, we increase the number of features to modify to enhance the level of exploitation. We start from iteration 1 to max iteration. We modify employed phase by adapted search equation. I will explain in the next slide. We modify also on local phase by the novel search equation and use the prior information about the best actual solution. For Scout phase, we keep it as the same standard artificial bee colony and memorize the best solution. The first modification for standard, we observed that for standard artificial bee colony, employed and on-local share the same search equation, which is here. V is the new search equation, X is the actual search equation, V is the new source food. In our case, this is the solution, this is the new solution, this is the new search solution. X is the actual solution. By this equation, we try to modify the actual solution by a new one. In standard ABC, G is selected randomly between 1 and the total number of features randomly. But the G is only one value. In our case, we change this code by iterating few iterations from for C from 1 to par limit, which is the parameter limit calculated in function function explained before. Here, computed per limit. This function calculates the number of features to be modified depending on the size of data. For example, for the size of data having less than 100 features, the number of parameters to change, the number of features to change is equal to 3. For the number of features between 100 and 1000, the number of parameters to change is 7. This table is followed in computed limit function. Then the value of parameter change according to the size of data, and we calculate the value of the new solution and apply greedy selection. We have the code of the enhanced employed novel search artificial bee colony from source 1 to maximum number of sources. The source here is the candidate solution. From 1 to source ND, we produce a new source VI from XI. Here we change by this loop from C to par limit and generate J randomly between 1 to ND features. Calculate this function. In the standard ABC, we calculate the new value of source using only one another source, which is K. In our case, we use two neighbors, two source food, and iterate parameter types. After that, we compute the fitness function calculated by accuracy of the supervector machine classifier, apply greedy selection, which is the comparison between the actual solution and the new solution. If the actual solution, if the new solution is better than the actual solution, we modify the best solution obtained, and update the counter of trial if the solution is not improved, and set this trial to 0 if the solution is improved. For on local B, we compute the probability value for food sources from source 1 to source ND. We generate a random number and compare it to probability of the source XI, which is calculated before here. We produce the new search equation VI from parameter 1 to parameter, and here we use the information of the actual best solution, and generate the new solution. Here we try to improve the exploitation process by using the best solution, and also use more features, involve more features in this code. We calculate the fitness function, apply greedy selection, and update the value of counter. We carried out the experiment on 5 data sets, which is hepatitis, WDDC, breast cancer, hemisphere, colon cancer, and DLBCL cancer. The size of features are presented below. This is a binary classification problem. The number of examples in each data set. We compare our approach, which is novel search artificial B-colony, with a standard RBC with other variant of artificial B-colony, RBC Zoo 2010 and Wang and al 2014, and particle swap. The result given using supervector machine classifier and 20 run, on 20 run, we calculate the SVM accuracy for training and test phase. We get the number of repeaters for each approach. Here we use two variants of our solution. Here we fix the par limit to value equal to 3, and here we use the table for different data sets that I showed before. The main result here will present that in our case the first variant of our algorithm present the best result for hypothesis. The second variant for WDBC and ionosphere present the best result for in terms of accuracy and number of features, minimum number of features. For DLBCL data set, we have also the best result obtained for farming with equal to 3 features, and exception for column data set, we have better result obtained by artificial bee colony of Zoo 2010. We conclude that our experiment showed that our two variants improve the accuracy and achieve minimal number of features. Applied to hypothesis WBDC cancer, ionosphere, and DLBCL. However, Zoo artificial bee colony variant is better than proposed algorithm for colon data. It has been found that the novel search artificial bee colony, the two variants of novel search artificial bee colony outperform the other variant of RBC and its distinct method. In this work, we can claim that this algorithm is give the promising result. We need to enhance to generalize to more approach and use more data set to certify the result obtained, and we need to point out that the number of features to choose must not be higher, because in this case we explore new solution and does not guarantee to get the best solution. So we need to be to limit the number of features according to the size of data set. They must not be so high. Thank you for
your attention. Yes, thank you. Now, if anyone has a question, she's ready to tell it. Okay, no question. I have a question about your objectives. You said that you are proposing a new algorithm. Is this a new thing you are proposing?
Here we have the same difference. Here is the insertion of this code. In the general code, we have in artificial bee colony we have this code. Sorry. Search equation. Well, in search equation standard artificial bee colony, J is a fixed value, one value of parameter, only one value of parameter, J. For our case, we increase the number of parameters. Why? Because we need to explore more features. because it makes standard artificial bee colony slow to converge. We have a drawback of slow convergence of artificial bee colony. In the actual work, we have one work in fetal selection where they use the number of it from 1 to number of fetal in data set, which is huge. If you have a grid data set, we can't use all features to modify them. Anyway, we have the problem of exploration. We explore a new solution completely different of the previous solution. For us, we need to search into, we need to balance between exploitation and exploration. Exploitation is about searching in the neighborhood of the good solution to get better solution. And exploration is about searching new solutions, to have a maximum diversity. Our problem is to balance between those two.
Thank you very much.